Good morning, good afternoon, good evening, wherever you are, and welcome to today's webinar, The Smarter Way to Manage Enterprise APIs. We'd like to welcome you today and hope that if you have any questions at any time, you'll just go ahead and enter those into the chat box or the question box, and we'll be happy to answer those as we get to the conclusion of today's webinar. I am joined today by Ryan Beck, a senior consultant here at Magic Software, who will be doing our demonstration of integration platform capabilities. And my name is Glenn Johnson. I'm a senior vice president at Magic Software Enterprises for the Americas, and we're happy to have all of you here joining us on today's broadcast. As we look at the capabilities of the various systems for integration today and start to talk about the smarter way to manage enterprise APIs. I hope that you will find this information useful. So we are now in the broadcast, and we invite you to enjoy today's presentation. The smarter way to manage enterprise APIs really came about as a result of a research process that had been going on here at Magic Software. And so today, as we review some of the material available in our ebook, we wanted to really highlight some things related to different kinds of integration and some of the challenges around managing APIs, and how there's really some better ways to intermediate and transform data and business processes between systems. So the smarter way to extend enterprise apps is something that's going to take us into looking at how effective IT organizations are managing API integration. We also have today the integration gap analysis checklist, which I think is another useful tool that you'll be able to use as a takeaway from today's discussion. So we begin by looking at how to overcome barriers to enterprise integration. APIs, of course, are designed to facilitate the movement of data, triggering of processes between systems, inbound and outbound. And each of the APIs that are published by various software publishers or organizations, protocol organizations, are capable of doing this for their particular domain, either a particular software application or a particular standard. And so APIs tend to then therefore conform to the internal data definitions of those environments, of those domains, and the applications that they're targeted to. And so they don't know the external ones that are used by other software applications. There is no universal data format or definition, no universal data dictionary, if you will, that are utilized by all business objects across all applications. As a result, there's this huge, Tower of Babel syndrome, where everything is represented differently. Even when the protocol for transport and exchange of information is the same. It might all be XML, but it's a different XSD, just to use the example of that one particular format. So with a look at how different systems are using things like RESTful APIs and HTTP, and how the syntax is always unique, we can very quickly get the idea that there's this concept of domain dissonance out there between APIs. And APIs by themselves are not enough. You've got to do something to intermediate between them. Now that can require a lot of programming, or you can use tools that allow you to automate that process. And that's obviously pointing towards that smarter way that we'll be talking about. Now one of the things that you want to do to overcome the barriers is to create event-driven architecture. With event-driven architecture, one API that has no idea what's going on in another environment can be triggered, right? It can be listening to what's happening in that other environment and find out. So since APIs don't have this mutual awareness, An integration platform for API management should use an event-driven architecture approach that allows business process orchestration to occur according to your business rules. Event triggers, event polling, and even scheduling of scheduled processes should coexist with other approaches such as messaging, publish and subscribe, store and forward, acknowledge on delivery, request and reply approaches, all of these kinds of messaging approaches. So in combination, you have an event-driven architecture which allows you to orchestrate business processes effectively rather than simply having to take a kind of a dead ETL type of approach. Now, data transformation, of course, is also a very big barrier, and since APIs don't have that common data definition that we really referred to at the outset, data mapping and data transformation are required elements of an integration platform. So you need to choose a system that supports a wide variety of inputs and outputs of sources and destinations, everything from flat files and XML and databases to even flow variables, so some of those internal notations related to the business logic of the integration flow, as well as things like operational metadata stores and even user-defined storage, as we said, on both the source and the destination site. And then you need to be able to do the transformation between all of that rich variety of sources and destinations, so that you need a capability for expressions, the ability to use numeric, string, logical functions, and operators, and so on. Third barrier that we talk about is this need for trans-protocol processing. So because APIs don't have the same transport mechanisms or protocols, you need an integration platform that will overcome the communication barriers between systems. Some systems literally don't have APIs that communicate in the same way. So an integration platform should be able to do things like use SOAP web services or RESTful web services. Should be able to work with a messaging queue, whether that's JMS or MSMQ or WebSphere MQ series, and other kinds of transport protocols, EDI, HTTP, FTP, flat file interfacing, whatever, and component architecture or compositing of business application logic by being able to call .NET code or COM objects or Java objects and classes and so on. Even when we're not programming, we might want to be able to access business logic in this fashion. The fourth barrier that we look at is that of process notation. Just the ability to communicate within an organization about these kinds of issues can become rather complex. We need some way to visualize this for business users and even for IT decision makers who are not directly involved in the systems themselves. So APIs tend to be not self-documented. They're not easily understood by business users. So an API integration platform should provide a way for process notation and business process modeling to take place. So models generally tend to fall into two categories. You have the reference model or the reference notation and an executable model or executable notation. And you're going to want to find the right balance between fine-grained and coarse-grained services in an object modeler that will enable business process designs to come together most efficiently. So when those charts and graphs actually contain the business logic and are executable, that's very powerful, because that means that you can not only visualize what's going on in the business process, but then configure it and go ahead and execute it. So when we're working with APIs, there are a wide variety of APIs, of course, and one of the new things on the horizon is the mobile API. There are a variety of these out there: client-side, server-side, enterprise application, mobile support APIs. And by this, what we're referring to is that with the client-side APIs, you have the ability to do things such as extending the capabilities of the client-side app. So you might be able to do barcode scanning. We have a barcode scanning API that's essentially utilizing the camera on the app, but processing a barcode through that scanner and returning the result to your main software application, which is then going to go ahead and use the return expected return information from that barcode format. Same thing, of course, with other kinds of QR codes and so forth. Now, a mobile server-side API is an API that's really designed to help your server-side application to deal with things that are traditionally in the domain of mobile environments, such as an SMS communications API. SMS communications isn't something that most server environments have dealt with in the past, so sometimes there are APIs that just make it simpler for traditional enterprise server-side software that might be supporting your app to be able to deal with things like SMS. And then there's finally the enterprise application mobile support APIs that allow you to interact with mobile protocols, like GPS and things of this nature across the enterprise. So these are, some examples of types of APIs that you might be working with in the mobile environment. Now, when you're working with enterprise APIs on the traditional enterprise software systems that you have in place, whether those are cloud-based SaaS applications, or if we're talking about even more traditional systems that are installed on-premise, there are a variety of different methods, obviously, that can be used. SaaS-based applications in the cloud tend to use SOAP and RESTful web services. Many older versions of enterprise software have other kinds of formats. If you look back at SAP R3, for example, which is still installed in many business organizations, much to SAP's consternation, I suppose, but it's still out there, and there, people are using BAPIs, and they're using ABAP and things of this nature. And so these are more proprietary business object formats that are designed as APIs, but are, in fact, essentially unique to a particular software application or software company in this case. So as you look at integration platforms, you see all the certifications, for example, that Magic XPI has, and a lot of the awards and so forth, the Salesforce Integration Award, App Exchange Certified by Salesforce, SAP Certified Integration powered by NetWeaver and so forth. As you look at enterprise APIs, you're going to want to evaluate them for how well they meet the requirements of the various APIs that you have in your environment. Are they flexible enough to deal with the broader requirement for technology protocols that you might need to use in order to interface with your software systems, as well as do they have some certified integration to those more important systems, particularly your ERP systems, such as SAP, your CRM systems, such as Salesforce, and so on. If those primary systems have certified adapters, then you're really in much better shape and condition. So we're often asked, what API types are best? What's the best API? And of course, that's very situational. I think I'd be interested to hear, kind of Ryan's answer on this. But the method officially supported and endorsed by each software cloud service provider is usually the best choice. And I emphasize the word usually because it doesn't mean always. It's usually the best choice. For one thing, you're on solid ground from a support standpoint. It also tends to be up to date and more effective. But by example, it may be possible to write directly to the database on a lot of situations, but it's preferable to use the published business objects of an API, obviously too important. RESTful APIs tend to be faster than SOAP web services, but SOAP is generally thought to be more discoverable. So you have pluses and minuses in both of those. And I know that there are debates that rage between different communities for these different approaches to web services, but at the end of the day, in the enterprise, we often don't have a choice. That sometimes it's just one or the other that's published by the software provider, and so we use what they provide. And so quite often the answer to what's the best API is the one that's available. And then, also you want to try to stay, generally speaking, with more recent methods. So if they're proven stable, then the more recent choice, because they're often, choices. If we look at a system like Oracle JD Edwards, there are multiple ways to integrate information and data within that one system. But generally speaking, the business functions, which are the most recent methods provided by Oracle for that type of interface, are preferable. And especially if the older method is deprecated, which means that at some point it's no longer going to be supported, then you want to move away from that approach. So an integration platform that needs to deal with APIs should have a variety of different characteristics. First of all, it needs to be able to work with both cloud and enterprise software. And to do that, it should obviously support publish and subscribe web services using either SOAP or REST. It needs to be able to transform, format, transport XML files, ability to composite application logic using Java classes, Java objects, .NET, COM, and so forth. Ability to monitor directories, parse text files, perform basic CRUD operations on text files is very important, because sometimes that's all that's out there. Let's be honest, that somebody created an old legacy system and it dumps out a TXT file. That's all that they could come up with for that system. Well, okay, how are we going to deal with that? We need a system that supports the ability to monitor directory, parse the file, perform basic CRUD operations on that file, and then resave it or transform it and move it on to something else. You want a system obviously with business process modeling, the ability to do orchestration, real-time processes, asynchronous processes, very important, and scheduled processes with a nice scheduler. You should be looking for automated data mapping and transformation, business process monitoring, so that you can see what's going on in the integration of those APIs, some kind of visibility into the world of your APIs. How can you manage them if you can't see what's going on? So you need a monitor. You need security compliance, so you need to be able to deploy behind the firewall as an option, on-premise, or ability to deploy in your private cloud and so on. And you need some scalability, of course, to that environment, and compliance with various SOA protocols. And then, of course, you want the ability to work with mobile. So we talk about scalability, but in today's big data hype, there's I think sort of a missed focus in that whole market discussion. And the miss in the focus is that we're calling it big data, which is really the problem and not the solution. So if we accept that enterprises today are under an increasing stress of big data or more information, and that is defined variously by different people, but generally speaking, when we talk about big data, we're talking about more unstructured types of data, we're talking about larger volumes of data, and we're talking about an accelerated pace of those high volume data sources. And so things like mobile devices and social media sources are creating more information out there in the world of computing. And as enterprises increasingly interface more and more with customers whose lives exist in these social environments and in these mobile environments, then it's very true that there are stresses and pressures on transactional processing. There are other just normal business growth and scalability is creating those stresses. The internet itself is creating the ability for large crowds of customers and transactions to be taking place across many organizations. Everyone's goal and desire is to grow, so you better make sure you have the scalability, obviously, to be able to do that. But how do you do that? And I think that's where the focus is a little bit lost, is that we talk about the problem, we don't necessarily talk about the solution, or we assume that the solution is somehow business intelligence. Well, business intelligence, helps us to solve one problem, which, what is the information, but we also need to be able to keep up with the scale of that information, and particularly in the context of our discussion today where we're talking about APIs, application programming interfaces, and integration. I think the real value is to have a discussion about in-memory computing, because with in-memory computing we have a way to solve the problem. We have a way to keep up with this incredible blast and scale of information, of unstructured data, of high volumes of data, of increasing acceleration of data, and we can do that with in-memory computing techniques that really utilize these three methodologies that you see identified here. The idea of dynamic scaling, where you have elastic partitioning in user spaces, you have an in-memory data grid, which utilizes co-location of memory and processing, so that you have that dynamic scaling possible across this grid of co-located memory and processing. And then you utilize techniques like mirroring service, where you're actually writing behind the actual event. So the final write to a physical database in SQL, for example, is taking place after the in-memory recording of that information. And because of the increased reliability and redundancy of large amounts of memory in computing environments today, you have the ability to do that, to utilize these in-memory grid approaches with a high degree of confidence that meets or exceeds even disk-based confidence levels in the reliability and idempotence of that information. So these three aspects of dynamic scaling means that it's going to take you in an area where you want to be able to use a middleware with an in-memory data grid that allows the APIs to be served by multiple server processes that are running on multiple machine instances. So that can be physical and virtual. And a space, as we refer to it at Magic, is really an area comprised of memory and processing capability that works together to store large amounts of data in memory and achieve high performance, dynamic scaling, and fail-safe redundancy, so that if one piece of the grid fails, there's other pieces of the grid that step in and provide that redundancy. So data and business logic in the space are replicating and partitioning across all machines in the data grid, providing a high availability even when those machines or software fail. So dynamic scaling is one of those secrets, if you will. Co-location of data and processing. So API processes execute as they enter the system. This reduces multiple network hops and the overhead of serialization and deserialization. You avoid a single point of failure. Co-location reduces transport requirements, thereby aiding the elasticity of the system through straightforward scalability and maintenance. And real-time clients are served by in-memory data aggregators and counters. So co-location, again, a very powerful concept that when applied in-memory computing, and we're starting to hear everyone talk about in-memory today, not only SAP HANA, but also Oracle's making a lot of announcements related to in-memory computing solutions, as are others, and this is a key concept in taking this approach forward. The third one is the idea of write behind. So in-memory computing that leverages write behind should provide reliable asynchronous persistency. And so this approach allows you to asynchronously delegate the operators conducted with an in-memory data grid into a back-end database. Significantly reduces the performance overhead. You use write behind to avoid the performance disadvantage normally associated with writing information directly to a SQL database in a hard disk type environment. So integration API metadata archived in a data store should be saved in background batch processes, which is write behind or archiving. So these three secrets, if you will, of space-based architecture really can be very valuable in an API messaging context, because if you have an integration platform that brings these in-memory capabilities to play, you get the scalability, you get the redundancy that you're looking for through these kinds of clustering approaches. So as we look at APIs and security, this is an area that unfortunately is often overlooked in these discussions, and I think it's an important one to realize that in the integration process you can't throw out your security precautions. So the essentials that we see here, first of all, in the area of user authentication. You want to review the APIs that are used in your integration scenario for compliance with the best practice for security in the area of user authentication. Acceptable approaches might include passing software-specific application user authentication or status from the source event to the destination API, using LDAP, Active Directory, or similar approaches to authenticate and identify them in a particular business process integration flow. The second area, of course, is user rights. So once you have an authenticated user, what are that user's rights? And what are that user's rights in the context that you're in at the moment? This is an area that we're looking at increasingly because with mobile in particular, a mobile user may have a different set of rights while they're mobile than they do while they're on-premise at a desktop system and known to be inside the facility of the company that's providing the application. So if they're known to be inside the facility, that's one thing, right? That's one secure context. Versus if they're mobile, that's a different context. And then a third thing that can take place with a mobile device is the mobile device can be online with real-time server communication taking place in the background, or that can be offline. Do the user rights need to differ in those scenarios? Not necessarily, but in many cases, in many organizations, as people think through what could be happening in those online, offline scenarios or mobile versus on-premise usage scenarios, there definitely would be a different set of user rights that would need to be ascribed, a different set of approaches and approval processes and everything else. So you want to review the APIs to be used in your integration scenario for compliance with security practices for user rights. So normally the user rights that are assigned and managed in each enterprise system prevail. But as we just described, there might be instances where you need to look at that and play with that. And these may be assigned to individual users or to an integration server acting as a generic user. And you have to decide which is the best approach. It's certainly easier to assign rights to a generic user, but it might not be best from a security standpoint. You have to consider all the possible business use scenarios and security breaches that could occur. So if access to the triggering application is secure, then it's generally safe to assign the group rights to the integration server. Solving user access issues at the application level for each application, therefore, is the best way to manage user authentication and security. The third thing is the idea of ciphering, or encryption and decryption. And all middleware layers that interface with an application API need to be validated for their ability to employ both encryption and decryption for data and metadata. So generally, middleware should support multiple options for secure encryption, such as the ones shown here. And we do have a technical paper on this, by the way, that allows you to compare, RSA versus IDEA, CAS, Blowfish, and so forth. So you can determine which ones are better. Some are faster, but they may have less secure, maybe easier to break. So you just need to consider, your particular context. Some companies worry about this more than others, and for appropriate reasons. Excuse me. And then the fourth area of security that we don't always talk about, but is also worth looking at, is how all the middleware layers that interface with your APIs need to be validated for their ability to provide an audit trail for traceability. The best way to do this is to include those capabilities in your integration platform. So if your integration platform has the ability to take an individual business process flow and its metadata, do the user logging, have encrypted data attachments with date and time stamping, and so on, then your monitors and logs can become useful for transparency purposes, for traceability in IT, and even for financial and hopefully not, but even forensic audit. So that type of information, if it's monitored, can be logged and that becomes very powerful as well. So as we look at how to work with vendors in this area, we want to look at the service offerings that they have and kind of consider how to evaluate them. So evaluating an integration services provider is obviously an important part of selecting your integration platform for your project. I think it is common sense that you need to be intentional about evaluating your services provider for their support capabilities, the training offerings that they have, their overall integration experience. And one of the things to do is to compare those service offerings that they have to your circumstances. So your service requirements definition will include a formal definition of the services that are needed, from consulting to project management, implementation, testing, documentation, training, and review perspectives. So you want to look at all of that. And then you can compare fixed price versus time and material approaches. Is the vendor willing to use your staff in the project? Do they offer mentoring services and take a collaborative approach? Or is it just all about them doing the work for you and sort of leaving you in the dark? And that's obviously, in many organizations, not the best option. You need to determine, therefore, the service provider's flexibility. Are they willing to provide services as you desire them, on-site, off-site, near-shore, offshore? What's the cost ratio that you're looking for? What's the level of service that you're looking for? And if they can't perform any of these, ask yourself why not, and how important is that to you? What is the process for change requests? How do they handle that? How is it built into to everything that you're doing? And is this a reasonable environment, something that you feel that you have very well defined and understood before any projects begin? You want to look at the support, the training, the implementation experience of the vendor. What kind of documentation do they have? Do they provide telephone support? Do they have online support systems where you can log problems? So many of the issues that are faced in enterprise IT today involve, formal evaluation of pretty technical information, and so, telephone alone just isn't enough, obviously. So what kind of online systems do they have available to help with this? And then the training environment, of course, is very important. Is there formal curriculum? Do they offer classroom courses? Is there online training or self-paced training available? What kind of mentoring services can they offer, and so on? And then, of course, the implementation of the integration platform or API processes needs to be looked at. You want to have a defined methodology, but at the same time you want to have a flexible methodology. And you want to obviously very thoroughly look at reference accounts and look at people who are experienced in a wide range of APIs. Those that you're directly concerned about, as well as maybe just the experience of working within many different environments and situations can also prove to be an important benefit. So you want to look, I think, as a key for ERP domain expertise. So integration platform vendors will tend to have extensive experience with the API integration, utilizing tools and techniques for integration, but you may need to team them with a local service provider who's experienced in your particular ERP system, the true ERP expertise. You may have that in-house, which is great, and we'll talk about that in the checklist, but you also may need to supplement that from a third-party or external organization. So that combination of local ERP expertise and direct vendor integration support is really ideal in an API integration project. So the integration gap analysis checklist, we're going to fly through here, but we wanted to talk about how you can really start to look at how to assemble a team and get the executive support, line of business support that you need, get the various project leaders, technical leads, ERP functional leads in place. You may need that enterprise security architect on that team DBA might be involved, and then what is the target system? If you're like using ERP as one of your main systems to be integrated, what's the target? Is it CRM? Is it an e-commerce platform? So you need a functional lead typically from these target environments as well. You need to establish scope is one of the key steps here. Looking at the scope of the project in the beginning and really firmly understanding that's going to save a lot of grief down the line. And then to do the gap analysis, first of all, you're looking at it from a functional standpoint, determining, the various common elements in the ERP system, their relationship to the data in the integrated system. You're going to be very precise here with exact field mapping and data translation requirements. You're looking at it also from a technical viewpoint, however, which is not just the function in its specificity, but also technically the table structures, fields, and so forth that are taking place and how those might need to be transformed, various exception flows that you need to consider, and other functions that will be needed. And we won't go into the detail here of how you examine these integration requirements in detail. This will be available to you, obviously, as a take-home document, and I think identify some of the key data, mandatory fields, and things like that that you need to take into consideration as you're doing your detailed gap analysis and checklist here. So the data mapping ultimately then becomes sort of that final view of what that gap is, and allows you to analyze your ERP transactions and so forth. So we are at a point here where I'm going to ask Ryan Beck to kind of make this real, and make it real by showing us a demonstration of how you can work with different APIs and create integration in a manner that kind of reflects the principles that we've been talking about up to this point. So what I'm going to do is share the control here now with Ryan, make him the presenter. So Ryan, you should have control now, and we'll ask you to go ahead and show us how this really works.
Okay, thank you very much, Glenn. So you can see my screen. What I'm going to do is I'm going to show everyone a live demonstration of using Magic XPI to connect two completely different type of APIs, two applications that otherwise would have no way of being able to talk to each other. So what we're going to do is we're going to connect Salesforce, which is of course a CRM system, but also an expandable system that might have, say, quoting and orders and customer service built into it, with an on-premise application, which in this case is going to be SAP. So what we want to do is get some data from our Salesforce instance back down into our server in SAP. So if I look right now, if I go into SAP, we have, of course, it's of course an accounting system. So you're managing your orders and your items and your sales and things like that. And my last order in here was done last week, and it was order number 30 that came in last week, I see. So I want to bring in a new order, but I don't want to just input it straight into SAP because that's kind of rather boring. What I'm going to do is I'm going to be Joe's sales rep, and I'm going to input the order into Salesforce itself. So I'm going to go into my orders, and I'm going to create a new one. And I'm going to be talking to my customer, so obviously I'll choose the correct account for whoever I'm talking to. And we'll go ahead and pick their PO number. So let's just call this approved by Glenn. Why not? And let's go ahead and ship it to another one of my coworkers, and we'll put some notes in here like this is a good order. All right, and why not ship it to our address here at Magic? So Good enough. So we've got our order header. And now what I'm going to do is I'm going to add some products to it. So I'm going to go ahead and add, let's see here, what do we want to buy? Some stuff in here. I don't know what all that is. You know what, there's some watches. I'm going to choose a watch here. That looks kind of interesting. And let's get 2 of those and add that. And maybe we'll add to our order one more thing. We're also going to grab, I don't know, whatever this is. Maybe I'll give myself a discount on it. We'll say around 1,600, and I'll only get 1 of those. So we now have our order header, and we have our order lines. So 1 quantity of this guy, of the Monaco, and 2 of the gold watch. And it calculated our extended price, and it calculated our total price up here, of course. So now what I'm going to do is I'm going to go ahead, and you can see I created this at 11:44. I'm going to modify it one more time, and I'm going to say that it's now complete. This is going to be a flag that's going to tell Magic XPI that this order is ready to go. It's going to launch what's called a flow, where Magic is going to pick up this data from Salesforce. It's going to transform it into a format that SAP is going to understand, and it's going to deposit into SAP and create a sales order. If everything goes fine, it's going to come back and update me and tell me that it was done by setting this flag here, created in SAP. I'll also see if it becomes modified as well. So I'm going to hit refresh in my browser, and I do see that it was now created in SAP. So that seems to have been successful. So I'm pretty confident now if I go back to SAP and I go to my sales orders and jump to the last one, I'm going to have order number 31 that was created today, May 7th. And we have, of course, the customer who chose in Salesforce. We've got the PO number that I put in there and all my little notes, of course. And then also in the order detail, we have the quantities and prices that I put into the into there. So this one was, of course, this watch actually had a different price available, but what we did is we actually gave myself a discount number. So instead of 1,680, it was just around 1,600, and that was affected then in SAP. So basically, we were able to do a real-time sync of data between Salesforce using sales orders and SAP using the same object. And it's all transparent to the end user. Joe Sales user doesn't really know that there is anything hooked into the Salesforce org that's going to pick it up and bring it over here. He's just going to input the data like he's trained. He doesn't have to have any software installed on his desktop, or he doesn't have to push any buttons to make it happen. It just does it automatically. And that's the cool thing about Magic, is we're using a server-to-server-based integration loosely coupled using correct APIs. That means that we don't really need to know an end user's credentials, and we don't need to have them run anything on their system tray bar or anything like that. Nothing funny like that. It's all centrally managed on one Magic XPI server. It has connectivity to all your APIs from there, calling web services on Salesforce, calling APIs on SAP, and basically syncing the data across them. Now, that is also much more, I would say, desirable than a lot of point-to-point integrations that people do, where they might just write a bash script over here that pulls data one way, write a bash script over here on another server, and then you end up with all these logs on these servers everywhere. You don't really see the big picture. So I'm going to show you how we can use Magic XPI to make that better as well, and show what happens when we centralize all of our integration logic. So I'm going to go behind the scenes now, kind of open the hood, and I'm going to open up what's called the Magic XPI Studio. This is a visual design environment where we create the metadata that says how to run your project. Most Magic XPI installations are 99% the same. It's got the same base code, all of our components, all of our adapters. What's different about from customer to customer is they have the metadata that says what they want that installation to do, or what that project to do. And this is where we create it. It's visual, totally code-free. It's made up of these little icons you see over here on the right of my screen. that tell it what steps to perform whenever it receives data. So in this case, it's querying an order from a Salesforce component, and it goes off and does some things and eventually sends it to SAP. And we design these flows by just dragging icons over on there. So if I want to work with some data in Salesforce, I grab the Salesforce component, and then drag it over and drop it on the flow, and hit Configure. And I can then go and choose whatever objects I want. So if I want to go and grab data from an account or a campaign or a case, doesn't matter. All the objects in Salesforce are exposed. That's because Magic XPI doesn't have templates that says, hey, you have to do this, sales orders or address book or something. It's totally configurable. We can see every object in each side. So if you decided that you want to, map leads from Salesforce to become contacts in SAP, doesn't matter. Whatever you can dream up, you can do. So I could say query a lead, or maybe update a lead as we go. Maybe I want to convert a lead. So I can do that as I go, and just say OK, and it's going to then expose the objects that are available, or sorry, the items that are available on a lead. So I would see all of the fields that are exposed. And that's important because no two Salesforce orgs are the same. People customize them. They make their own custom objects. They add fields to those objects. They add data validation and rules to those. So the tool itself, Magic XPI, is used to be able to exceed those customizations, expose them, bring them to the surface, and allow you to program with them at a higher level, so that you're not just say getting into the weeds of how do we connect to SAP or how do we connect to Salesforce. All that's handled for you, and then at a higher level, you're just going to kind of connect the dots between them. So let me show you what that kind of looks like right here. This is this SAP component that created our sales order. And over on the left, I have our Salesforce data. So you can see that lined up. And over on the right, I actually have our SAP sales order. And it's got, you can see it's kind of a complex XML file. It's got a document header, which we can map into, and it's got document lines we map into, because there might be more lines than headers, right? So this is just showing how we create the mappings between the two. It's really simple. We just kind of drag stuff across. If I want to put something into the, maybe I want to set the transportation code, because I noticed I forgot that. We can go ahead and map the transport code across from one side to the other just by drawing a line across, and then there we go. And if we want to do any conversions on that, maybe we want, maybe I know that in SAP it's a number, and then in Salesforce we want to show the English transformation. So we can go in and we can do make a very simple statement and just say if if the source is equal to ground, do 1, otherwise do 2. And what that does is it's while it is totally code free, we do allow you to use expressions that let you convert the data from one side to the other. Because in integration, no two sides will always match up one-to-one. When you take different applications, they don't have the same concepts. So in integration, we do transformations a lot like that. They allow you to just say, okay, well, if someone chooses ground in Salesforce, let's make that become a 1 in SAP. And then the two sides can now talk to each other. Otherwise, they wouldn't be able to do that. You'll also see that we can hard code some stuff here. Maybe we have hard coded dates or things like that that might be useful. And the mappings are just really simple and quick. And every component out there in the tool set has a data mapper. So this data mapper can be used on Salesforce, on SAP, on SharePoint, on web services, all different types of things like that are exposed by the data mapper all over the place. There's a lot of different components that exist in the studio. So we have things that are application specific, like Salesforce and SAP R3, JD Edwards and SharePoint, and maybe more things like Dynamics or Exchange. But there's also ones that are more generic as well, that really open the doors to allow us to go out and hook into anything. And ones like that include our data mapper, which works with flat files or any type of database like MS SQL, Oracle, DB2, anything you can get into with ODBC. Flat files is great for working with physical files, like if you have the CSV or you have a delimited file or something like that. It's sort of the old way of integration. We can still hook into those processes. As well as things like HTTP and FTP, which are pretty common for moving files around if you need to get them from a remote location. And also good old web services, and we can actually even provide a web service or consume it, whichever way you want us to go. If you want other applications to call Magic, or you want Magic to call them, we can go both ways with it very easily. And of course XML as well, because we do work natively with XML. And all of the components can talk to any of the other components. So if you decide I want SAP to talk to Dynamics CRM, no problem. You can make that happen. There's no limit to how what you can design on the flow to make that happen. All of this is then you design your project visually here. You kind of make up your kind of design your flow. And then you build it and it runs on a server, and then what happens is it gets run then on a Magic XPI server. So the studio goes away. Everything's kind of just then running behind the scenes. You just have your SAP and your Salesforce. You don't really see Magic. It's just kind of behind the scenes. Well, we have a Magic XPI monitor that allows us to see what it's doing right now. So I can see that my Salesforce to SAP project is running, and I can see that it's how many threads it's using right now, which is basically how many of our engine it's using, and I can drill into it actually, and then say, okay, let's see what it's doing right now. Before I do that, I can also I can go and start and stop other projects. I can bring them up, bring them down. The tool is totally reusable. So once you've built, you can see I built the Salesforce to be one project. I can also go start my J.D. Edwards project at the same time. They can run in parallel by each other on the same server, reusing all the same hardware. No reason to go and do that. So now I zoomed in on my one project, and I can see what it's doing now, which is way too much information. So I'm going to filter it down, and I'm going to look at maybe only errors. Maybe I want to see whenever there was an error, which there aren't any, so okay. And then I'm going to look at only when there's logging data for components, which there's not any right now. So basically, I can go in and get a feel for what happened when it ran. Did it talk to SAP? Did it set it handled back in Salesforce? So I can actually go in and zoom in and see the data as it came through. And just make sure that everything's up and running and control it, and if it's not running, just hit start and bring it back up. So then the XPI monitor is a useful tool for that. I'm really short. I think I'm down to 2 minutes now, which I thought I had more, but that's okay. Glenn, do we have any questions that we want to answer? I can't hear you if you're talking.
Oh, thank you. Thanks, Ryan. If you have questions, please go ahead and type them into the chat or question box, and we will take a look at those. So while we're waiting for you to do that, we'll just mention that the Magic Users Conference 2014 is coming up at the Hilton Waterfront in Huntington Beach, California, June 2nd to the 4th of this year. We certainly want to encourage those of you who are looking at the Magic XPI integration platform or the Magic XPA application platform for enterprise mobility to also consider attending this event. It's a great way to learn about what's going on, and for those of you who are currently using, of course, it's a very great kind of advanced look into both platforms and environments. We have 3 tracks this year. We have a Magic XPI integration track, so full deep dive into all of the XPI issues for integration around Magic XPI, what was formerly called iBolt, and then deep dive into the enterprise mobility So there's a complete track there, and then we have a third track, of course, for the Magic XPA application platform. The nice thing about separating out that enterprise mobility track from the Magic XPA track, for those of you that are users there, is that you get in-depth in both areas rather than kind of half and half, which we would have had last year. So I think that's really exciting for people. So we'll go ahead and look now for those questions, and just go ahead and type them, as we said, into the question or chat box. I see some coming in. So let's see. One question is, what is the access code for the telephone? Okay, sorry, I'm sorry I missed that one. That was right up at the beginning.
42.
Hopefully they found that. What is the status on integration with SAP HANA?
HANA has RESTful APIs, so that should be able to work no problem. It's kind of new to us, so we're still learning what it could mean.
All right. And that question, by the way, Ryan, is coming from Tom Arnold. I think you know Tom over at ECS Online.
Oh, yeah. Hi, Tom.
So he probably would appreciate a follow-up on that, too. Okay, that's a good question. Let's see if we have any others that are coming in here. Actually, that's the only question I see. I know there's a lot more of you out there that are on the webinar, but, oh, wait, here comes one from Isaac. Is there a list of all of the connectors for XPI? That's a great question.
I think there's one. I think there's one online. We can direct them to it, or we can give them a list if not.
Yeah, actually, I can answer that. The complete documentation is online, and if you go to the Magic website, www.magicsoftware.com, up at the top you'll see a word that says Communities. You click on Communities, then there's an option for Library. Click on Library, and you'll see that you have full documentation for the current versions of Magic XPA and Magic XPI. And in the Magic XPI documentation, there's a folder with a plus sign on it that is called Components. So that explains what all the components are. Now, one caution, and Ryan, you might want to explain this a little bit better than I can, but Components is not the only list of interface capabilities that you have. So you also have, you know, the services and methods. You want to explain kind of what the difference is for those that are new? Ryan, are you there? Well, we seem to have lost Ryan. I'm sorry, Ryan, if you're speaking, we can't hear you. Over here, we can hear you before. All right, so let me see if there are any other questions coming in. Sorry, this interface in GoToWebinar is just a little bit difficult to see. Is there a way to get the XPI sample projects installed on the server without having to go through the installation? Ryan, are you there? No, we've lost Ryan, so I do apologize. I have to look at that one. I think that would be a question for Ryan, so I see that coming from Corley. We'll get that question answered for you offline. All right. Thank you very much. We've run out of time. I apologize for going a little bit over, and appreciate all of you joining us today here on the webinar. We hope to have you again on another Magic webinar very soon, and I hope to see you all in Huntington Beach for the Users Conference. Have a great day.